So today we're going to introduce the topic of slope, and we're going to basically be asking what is slope and how can we find slope or find the slope of a line by looking at a graph. And really the first thing we should talk about is that slope is talking about the steepness of a line. And we read graphs from left to right just like you would read words on a page. So on this particular graph, we're starting at the left-hand side, and as we move across the graph, what's happening to the lines? They're increasing. Each one of these is increasing, and we would say that that has a positive slope. It is increasing as we move across the graph. On the next one, all of these lines as we go from left to right are decreasing. So these would be called negative slope. Okay, they're going down. So any line that as you move from left to right, if it's going downwards, if it's angling downwards, that's going to be a negative slope. Next, we have a line that goes just straight across the graph. This one, we're going to call that a zero slope. Okay, so any line that's just flat, that's just horizontal on the graph is called a zero slope. And finally, the last type of slope we have is a vertical line. And these vertical lines we're going to call undefined. So anytime you see a vertical line on a graph, it's called an undefined slope. And we're going to talk more about what makes it undefined a little bit later. And once again, on this slide, I really just want to reinforce the fact that we always read graphs from left to right. So now we're going to talk about how do we determine the slope of a line by looking at a graph. A couple of things we need to remind ourselves of is on this x-axis, as we go this way, we're heading towards negative x numbers. And as we go this direction, we're heading towards positive x numbers. Okay. On the y-axis, as we're increasing, these are positive y. As we're decreasing, these are negative y. Okay. One more thing to talk about before we jump into actually finding slope on this line is that in math, we always refer to the slope as the letter m. So most of the time, if you see the letter m in an equation, it's going to be referring to the slope of a line. We talk about the slope as being the rise over the run. Okay, so the way I like to think about it is the rise is our up and down motion, just like sunrise. And the run is our side to side motion. Okay. So the way we begin to look for slope or to identify the slope of a line is we have to look where our line crosses one of these little points right here. So one of these intersections. Sometimes I refer to them as crosshairs with my students. Okay, so we're going to find one of those, and then we can just move up the line and move to the very next one we see. We see, oh, there's another one right there. Okay. So next, we're going to find the rise and the run. So if we move upwards, so to get from here to here, our rises, we're going to go 1, 2. So we're moving upwards towards positive y 2 spaces. And we're moving towards the x 3 spaces. Moving towards positive x 3 spaces. So that's going to be positive 3. So our rise is up 2 and a run of 3. Let me erase that. Okay. Now something's interesting on this line. If we take a look at two other points, okay? So let's take a look at, say, this point right here, and let's go all the way to this point. Again, our rise. Okay, so if we're going to go up 1, 2, 3, 4, so we have plus 4 as our rise, and our run is going to be 1, 2, 3, 4, 5, 6. So plus 6 is our run. We come over here and we say, okay, the slope, we just determined that our slope was 4 over 6. We say, well, geez, those look like they're different slopes. But if we reduce this fraction, 4/6 will reduce to 2 over 3. And so for any line on a graph, we can look between any 2 points. Any 2 points on a straight line will have the exact same slope. You might just have to reduce the fraction. So now let's practice plotting some negative slopes. Let's start with this top line over here. We can pick one of the spots where the line crosses one of these crosshairs. Let's say we're going to start at that point right there. Then what we're going to do is we're going to move down to the very next one that we see. Say, we've got another one right there. So we're going to start with our rise. Our rise is the top part of the fraction. So we start here, we're moving to this point, we're going to go down 1, okay? So our rise is a -1, and our run is a 1, 2, 3, 4. So we can say that the slope of this particular line is a -1/4. If we move to the middle line, let's say that we're going to start at, this point right here, and let's move to this point right here. Okay. So again, our rise is on top. We're going to go 1, 2, 3. So we have a -3 rise, and our run is 1, 2, 3, 4. So that's a +4. Okay. Something I want to point out is that you can, even though we read graphs from left to right, you can read them backwards as well. So let's say that we're going to start at this point and we're going to move back up to this dot right there. So what we can do is we can go, well, our rise is 1, 2, 3. So our rise would be a +3, and our run would be 1, 2, 3, 4. So we went up towards the positive y, so our slope, or excuse me, our rise is a +3, and our run, we're moving back. We're moving towards the -x. And so our run would be -3/4. These are both exactly the same slope. A -3/4 is the same thing as a +3 over a -4. And finally, one last negative slope. Let's go ahead and start at this point, and we're going to move down to, let's say this point right here. Okay. So we're moving downwards. We started at this point, we're going to go down. So it's going to be 1, 2, 3. So the slope of this line, the rise is a -3 and the run is a +1. Okay? So the slope of that line is -3/1, and sometimes it will be written as just -3 because, okay, we're going to do a couple of positive slopes. So let's go ahead and start at this point right here and go to there. So this one, for example, is going to be a +1, so we're moving upwards 1, so the slope of this one is +1, and then we have 1, 2, 3. So then we have a +3. So the slope of this line is 1/3. Now, just like I said, we can work backwards on a line. So let's say that we're going to start at this point, and we're going to work back towards that point right there. So what we do is we're going to say, well, our rise is going to be a -1. And then we're going to move back towards the x, so our run is going to be negative, and it's going to be 1, 2, 3. So our run is a -1/3. And this -1 over -3 is the same thing as a +1 over a -3. The negatives basically just cancel each other out, and it will still be read as a +1/3 slope. Finally, we have this last line. We have these 2 points right here, and this one is going to be our rise. So our up and down motion is we're going to go 1, 2, 3. So we have a +3, and then we're going to move towards our +x for the run, 1, 2. So this particular line has a slope of 3/2, or 3/2. So now we're going to talk about the last 2 types of slopes. We're going to talk about a zero slope, which is going to be this horizontal line, and an undefined slope, which is the vertical line. We're going to talk a little bit about why we call one 0 and the other one undefined. So once again, if I start, say, at this point right here, and I'm going to move towards this point. Well, slope, as usual, or as always, is rise over run. So what is the up and down between these 2 points? We have a 0. There's no change in the y values. And if we go from our runs, again, if we start here, we're going to go 1, 2, 3, 4. So we have a slope that is 0 over 4. And any time we have a fraction with a 0 on top, that is exactly the same thing as a 0. So you can see that a horizontal line will give us a slope of 0. Now let's move on and talk about the undefined line. Okay. So an undefined line, once again, slope is the rise over the run. So let's pick this point and say this point. Well, what's our rise? If we start down here, our rise is going to be 1, 2, 3, 4. So we can have a positive 4. What's our run? What's our side-to-side motion? Well, there is no side-to-side motion, so that would be a 0. And anytime you have a 0 on the bottom of a fraction, that is called undefined. And I'm just going to write UND to represent undefined. Now, this always kind of messes with some of my students. They understand the other parts, but they say, why does this not work? Well, if we scroll down and I take you way back to the beginning of when you first started talking about fractions. Okay? A fraction, the most basic way to look at it would be the bottom number is the number of pieces you might have in a whole pie, like say a pizza when it comes out of the oven. And the top number is the number of pieces of that pizza that you have left. And we can draw pictures of that. So I can draw a picture of 1/4. Okay? 1/4 basically means when the pizza came out of the oven, there were 4 pieces in that pizza. And we currently have 1 piece left. That makes sense. I can draw a picture of that. Okay? I can even draw a picture of a 0 fraction. Okay? So if I said 0 over 4, well, the pizza came out of the oven with 4 pieces in it. And right now we have none left, so it's an empty pie shell sitting there. That makes sense too. I can draw a picture of that. But the problem comes in if we put a number on top and a 0 on the bottom. Then if I ask you to draw a picture of this one, it doesn't make sense, because how can I have no pieces to start with, but then all of a sudden have 4? It just doesn't make sense. And so that's why we call it undefined. It is undefined because it just doesn't make sense in our world.